Okay, so hi all. So this is going to be our day 4 for Google Cloud Fundamentals training, and the topic that we are going to cover today are Google Cloud Storage Services, which will include the introduction to Google Cloud Storage, how we create or manage the buckets, how we upload any objects to the bucket, and what are the various data transfer services available with GCS, that is Google Cloud Storage. Also, there are few more options available for storing the data. When I say the data here, this data is going to be something like a block storage, or you can say the object, like images, the files, videos, right, or some unstructured data. So that is what we are going to focus. So the other services can be persistent disk, okay, and the file store. So these three options that we get when we are talking about object storage. Okay. Also, we'll be covering two labs. One will be compute engine instance creation with different base, and also we'll see how to create a storage bucket with using the console, gsutil, and the Terraform. Okay. So let's get started and explore what we have for today. Okay. So let's open it in a different screen. So this is going to be cloud storage. We'll learn what is cloud storage and the various aspect of it, the advantages, the use cases, what is the pricing model, how we use it, right? What are the transfer services? So let's share a different screen where I can actually do some switching as well. Okay, fine. So as you can see on the screen, Google Cloud Storage, it is a global, secure, and scalable object storage. Okay. So first thing that we see here, it's a global service provided by Google Cloud. Now just recall, we talked about the networking part of the Google Cloud, right? So you had at the very outer layer the VPC, where you have the very outer layer as the network. So now in that network, so it is going to be accessible not at the zone, not only at the region, but it is available or it is accessible at the global level. I mean that you can access this service from any part of the world. Okay. So simply putting that, you can access it from any part of the world, and that is how it is a global service. Okay. Now it is secure in a way like you get data encryption, you get the ways to only provide access to the storage to limited people, creating some signed URLs. Okay, and there are different other means to secure it. Now the data that you can actually save or store on the cloud storage are going to be .png, .jpg, like the images file, video files, .mpg, or any other block storage. I mean, any unstructured data that you want to store, that will be saved in cloud storage, because uh, uh, other options or storing the data have a specific format requirements. Here, when we talk about the block storage or the object storage, they don't go with the structured format. Okay, it is a piece of data, can be anything. You just want to store it somewhere, right? That's why we say a block of it, an object, nothing much. Okay? Now, so how does it work? Let's see that. So you got an image, you create a you got a image here, you create a bucket, okay, and the bucket will be created within this cloud storage. So whenever I want to store any images, first of all I need to create a bucket in the cloud storage, and that is, bucket will hold my object. The object here is image. Okay. Now the size of the image can be at max about 5 TB. One object I'm talking about. Okay. So you can see the amount of scalability you have, the amount of data that you can save, that is tremendous. So here you can actually store so huge data, and that is also just for single file. So a single file itself can be about 5 TB, which is very rare, right? But that is the capacity that cloud storage has. Now this cloud storage, the object or the bucket that you're creating, that will be part of a project. Okay, where are you going to create the project? That will be created in an organization or an individual project. We'll be seeing that during the lab how it looks, but for now just park this in your mind that we are creating a object storage in a project which is going to be part of an organization or without an organization also. Okay, now so far if you have understood what is an object, what is a bucket, where we are storing in a Google Cloud environment. Now let's see what are the various storage classes. Now when I'm talking about the storage classes, they are defined based on how you want to store your data, right? Because they are based on the budget, the availability, and also the accessibility of those data. Let me know if it is visible to you clearly, or I should enlarge it more. Okay,
it is
so it's
visible,
visible, right? Okay. Now, if you see here on the very right hand side, you have the standard, nearline, coldline, and archive storage classes. Okay, these classes are defined. So when I talk about standard one, this is like you are going to access this object or the whatever data you stored that you are going to access on daily basis. Okay, or if not, at least monthly once you I mean not once, at least twice. So monthly once is going to be nearline, but if it is going to be less, more than a month of timeline, then you have to keep your data in a standard storage. Okay, so this is how it is created. It has a different set of properties that will help you to easily make it accessible. Like it is going to create multiple copies. It is going to keep it in a hot air where you whenever you want, you are going to be able to access those data. Okay, now the next one is nearline. So nearline is like when you convert, when you set the configuration saying that I want to store it in a nearline, that means you should be accessing the data only once in a month. In case you have a need to take that data before 30th of a month, once in a month, then automatically it will charge you for a standard class. Okay, similar to that, as we move forward, we see that if you are going to again access some data only once in a quarter, okay, it has a different use cases based on that these classes are defined. So now suppose you have a need for accessing the data only once in a quarter, and then keep it again back to this class. Okay, like suppose you want to have some reportings to be done every quarter. Okay, or you just want to validate your data is still fine, because from the security perspective you want to keep putting a check there, right? So suppose if you have a need for accessing the data only once in a quarter, then we are going to store it in a code line class. Now if you have a need only to access the data after like a year, or maybe you are not touching even after a year, like it is just that you have organization requirement, policy is in place where they say that we have to retain the information, the data for at least 5 years, 10 years, or maybe 15 years, depending on like you have needs for storing the records, right? Like how you used to do for the offline, you keep the record somewhere in the warehouse somewhere, right? So similar to that, you compare it now. In case of digital form, when you have the data, you want to retain it for upcoming few years, there you can store it in the archive class. So archive class is like if you are going to access it only once in a year or after that. Okay, now down here if you see, there are versioning options available. So object so here we talked about the storage class, like the how the buckets are designed and how the storage classes are defined. Now if you see, we have the object lifecycle management as well, right? So how the versioning is taken care of. Now suppose in the standard one you have a new version, after 30 days we are moving it to nearline, so it will create another replica for it, or if we don't want to maintain multiple copies, it is going to archive just the original copy somewhere in the nearline, code line, and to the archive. Okay, there is an option to auto provision or auto version your objects. Okay, so whenever I say auto versioning, I can just enable it in the console or through the programs, saying that okay, whenever I'm going to create a new copy or I update that data, the previous copy should be auto should get auto versioned, and then previous copy should be available for me instead of overriding the existing data, right? So you can probably see it happening whenever you are working with Google Drive. If you have created any documents, we will see that definitely. So you have the better insight. I will share that screen. So we will understand what the versioning means here and how important it is. So whatever amount of work you must be doing, suppose you could not save it or something happened, right? Or you know that the new version that I created may not be looking good. I will have the capability to always go back and look at what all changes I made in certain period of time, and I can take the previous copy and start working on that again. Okay. Now, how to use cloud storage? So you can access cloud storage in multiple channels, multiple ways. The very first is online transfer. So you can access it using the API calls. You can have a UI from where you can actually call it, or you can use the gsutil command line. Gsutil you can run either using the SDKs installed on your system, or you can use Cloud Shell and execute the command on the Cloud Shell to create, manage, upload data, whatever sort of things you want to do with cloud storage that you can do here. Okay. Then the other option would be data transfer from other cloud and on-premises. This is a use case that I had implemented, brought about 240 TB of data. I have published a Medium article also on the same. So in this scenario, there is another service provided by Google Cloud, which is called data transfer service. Okay. Now using the data transfer service, I can enable the connection, create the connections, and push the data to cloud storage. Okay. So I can bring the data from on-premises, from other cloud to the Google Cloud storage, and that becomes the part of the migration approach, right? Whenever we are actually migrating any applications or any sort of migration that we are doing, the very first thing that we start with is bringing the data, because that is not impacting anything, and that is easy to start with. Okay. So that is how we plan out and we look into that. For now, just see that data transfer service is used for transferring the data from on-premises or from other cloud to GCP. Okay. Even if you don't want to spend a lot of time, so there is a time constraint, there is a huge amount of data, like if you have 100 TBs plus of data, then in that case you can go for the transfer appliance. Transfer appliance is a device, so it's kind of, you can say, a case, like a, what you can say, a suitcase kind of scenario, if I try to make that sense. Okay. So you will have a device, hardware, where you can actually offload the data from the other cloud or the on-premises, securely save it, encrypt it, and then bring the data. So this device is provided by Google itself in certain regions only, not available everywhere. As of now, I believe it is only limited to US or maybe some other continent also, if they have enabled, I think in UK or somewhere. So using the data transfer, transfer appliance, you can do the transfer using offload method or offline method. So you will get the data from on-premises, encrypt it, keep it encrypted until it is transferred to the Google's own data centers where they want to actually keep this data. So then it will be uploaded. This is the fastest one because it takes very less amount of time. Okay, depending on the data size. Okay? So, and there is another way that we do it using the API calls. So API calls, Naresh, you must be aware that how API calls are working, and you must have tried out some of the things. As you said, you worked with S3. So similar to that, cloud storage also perform. Okay. Now from security aspect, all the time we will have the data encrypted. So by default, Google ensures whenever we are exchanging any of the information, the data gets encrypted as soon as it reaches on Google Cloud environment. Okay. Also, if suppose you want to store your data and want to use your own encryption key, or you want to manage the encryption keys that is being used instead of relying on what default provided by Google Cloud, you can have that option as well. So you can manage the key, like you can create the key on the Google Cloud itself and then encrypt your data. Also, you can bring your own keys, but there are drawbacks also, like you have to take care of maintaining it, rotating the keys all the time, so that it keeps on secured, right? So that is what you need to take care of. Okay. Now from the pricing side, if you see, so you will have the cloud storage pricing going down as you move from the classes, like from standard class to nearline to codeline to archive. So that keeps on reducing because the frequency of access of this data becomes less and less. So they don't have to, I mean, they can keep on compressing it, right? So the kind of encryption that is not only encryption, but the compression that is happening at the Google end, that will keep on increasing when you are moving from standard to the archive. And that's the reason, even if you want to access them, so the access charges is going to be a lot. So you have to incur a lot of charges for access, but for storage it is going to be very less comparatively. And actually this is very rightfully crafted in this graphics, that the amount of charges that you are going to pay for archival, that is somewhere 4x less than what you have to pay for the standard one. Okay, so yes, that is how it works from the pricing perspective. Also, now let's see what are the use cases or the examples of cloud storage different classes. So you'll have the data stored in the standard one, like if you want to create some static web pages, websites, this is for static one. We are not talking about the dynamic web pages. Then if you want to stream some data, so you are going to keep the data in cloud storage and stream it all the time. So that is where it can be kept in standard class. Or if you want to access some documents all the time, then again you can keep in the standard class. Now, suppose if you want to create only the backups, you have all the setup running in your on premises or maybe some other cloud or even on the Google Cloud itself, but you also want to create backups for security perspective and for also for the high availability aspect. Okay, so in that sense, you need to create the backups. The backups are created either in the near line or the code line based on your use case. How frequently you may have a need, how frequently you are going to look for those backups, right? So they are defined accordingly. Okay, and as I have mentioned, if you have a long-term need of like you want, there is a organization policy, there is a government initiated policies that you have to ensure to retain the data for a long time for maybe the analysis perspective, or you want to keep it also like there are some dispute happens and you want to go back and then see what happens earlier. So in that scenario, you have to archive the data for a long time, and that is where you will use archival. Okay. Then there are multiple integrations that can be done with the Google Cloud Storage. You can integrate your batch processing, streaming data, or working with the AI models. Like you want to store the data, use the training set, test set, like that. You want to have the integration with the BigQuery also. Like the BigQuery is a data warehouse. So whenever suppose you don't want to perform the analytics all the time, you don't want to store the data in BigQuery always. So even you can store the data in cloud storage, and from BigQuery you can run your SQL command, which is going to extract the data from cloud storage. Only the amount of information that you need, that only going to be taken into the BigQuery. Otherwise, the data is still present in cloud storage itself. So you are not bringing it there, and that is how you are actually saving the cost as well. Okay. So that is all about cloud storage. We'll see a little more when we are going to do the labs. Okay. Yeah. So let's take some questions now. Any questions?
Okay, now it is fine. In the AWS, different cloud storage types are there in the terms of S3. Snowball, like that. Is there any other options in Google Cloud, or only these four types are there: standard, nearline, codeline, and archive?
Yeah, they are four, and they are very much similar to what you have on
in AWS.
On the AWS also. Yeah.
Okay, like that. Okay.
Yes. Okay. Now let's move next, and let me share the other screen. Can you see the persistent disk? You can see that, right?
Yes.
Okay. So before I move to persistent disk, any more questions on the cloud storage? Anything that you think is not making sense? No?
Can you give the Medium article link for that one to read that one? Because nowadays migration is one very big project, or always interview they are asking. If suppose that 100 TB data is there, how you will migrate? Suppose that I will say one story, fake story. Okay, in my company, if 100 TB data was there, we have migrated to AWS or GCP, anything. So we have to tell each and every step before and after the migration. What are the things you have taken care or not? Okay, like that we can you explain that one in that Medium article? That will be better for also to learning how it will happen.
Sure, I will do that. I will share with you the article with you all.
Okay, thank you.
Okay. Now let's talk about the persistent disk. So the very first we saw about the cloud storage. The second one is a persistent disk. Also, it is also going to be a block storage, which can store any sort of data, not only limited to specific formats. Okay. Now, so whenever you are purchasing any laptop or any desktop, you will see that you have a hard disk attached to it, right? That is how you are able to do any sort of work. Okay. So here, same scenario in this case also. Give me a second. Let me change the. Okay. Yeah, this one is better. So now, when we are talking about the persistent disk, a disk which can persist, that is what it means. Okay, very simple term. The disk which can persist, it is going to be an external hard disk if you want to make a more comparative understanding here. So this is what you are going to attach to your compute engine or the Kubernetes engine. Yesterday also when we were discussing the concept of Kubernetes, we saw there is a persistent disk concept also there, right? Now, in scenario wherever you want to keep your data even when the machines are shut down, you have to use the persistent disk, right? So it supports multiple reads all the time. Like you create one persistent disk, attach it to a compute engine. So either compute engine or Kubernetes engine, they are behind the scene. They are an operating system, virtual operating systems, right? So you attach to that. Okay. Now, if it is attached to one operating system, you cannot let it write, or you cannot write to that disk from the other machines, but you will have the access to read only. So that is what it means. You have a support for simultaneous readers. So you can have multiples of other instances, compute engine or Kubernetes engine instances, which can read from this disk, but they cannot write. Also, they have the transparently resize, so you can resize them as you need. What I have learned is that it can only grow, it cannot be reduced. So suppose you have started with some 10 GB of persistent disk. Now you want to add more space. So you can add like increase it to 20 GB or maybe 100 GB like that. Okay, as the use case grows. So that is how you proceed with it. There can be two types. Now let's talk about which block storage is right for you. There are multiple options here, right? So you have a persistent disk as a standard, balanced, and the performance based. So standard is something that is attached with, I mean, by default, it is attached whenever you are creating any uh, computer engine services. Okay. So that is where you have a standard throughput, and it is very much cost sensitive. So it, I mean, whenever you are going to work with standard percentages, it is going to give you the right balance of costing, because you are not going to use it for longer time. I mean, the computer engine with which it is attached, you may not be using longer. You just need it. I mean, per usage basis kind of scenario where you want to use it for certain like office hour and then you close it, right? So that is where it is better. Now, if you want to have even better performance or better balance between how much you are going to use, but whenever you are going to use, it is going to work for the most of the workloads that you are working on. So in that scenario, you want to increase it. So these are like the optimized way of creating those multiple options. So the third one is the performance based. So you have performance based SSDs where it is going to give you the best price for I mean the multiple IOPS operations that is happening in input output operations that is happening. So for that you are getting better performance. In that scenario, you will go for the performance SSDs. Okay. And again, then we have the extreme requirement of the performance. There you are not going to compromise on the performance side. Then you can go for the extreme performance based SSDs. So SSDs are kind of accelerator whenever you are actually working with your operating system. Okay. Now there is another model which is a local SSD, which is actually having very low latency because it is directly attached to your machine. It is not a persistent one. Okay. So when we use local SSDs, they are giving you more memory for the operating system when you are performing any task. So they will be suiting more for the analytics purposes, where you are performing some computations for analytics perspective, and you need a lot of memory there, right? You want to cache a lot of data there. So in that scenario, you will go for local SSDs, which will have the least latency. Okay? And you will have the local caching, and when I say hot layers, like you have the data available all the time, but only concern is that as soon as you shut down the operating system, the local SSD will be gone, because they are directly attached to the your device. Okay, so as you can see how to pick based on the availability needs, you can see here. So local SSDs are ephemeral in nature, so they will be there as long as the machine is up. After you have shut it down, it is gone. Okay, now they are stateless workloads or replication managed at a application or database layer, so they are not going to sustain afterwards. So that's where it says it's a stateless device or the SSD. Okay? Then the persistent disk and the regional persistent disk. Now there are two versions. There is a persistent disk which is going to be available just within a zone. You see, global, regional, and zonal. Now the persistent disk, the one which is going to be in the zonal region, so you can actually keep on creating the snapshot, but they are not available within the, I mean, at the region level, because so only disadvantage that you get is, suppose these are the data center, these are the setups that is running, right? Suppose there is a failure in one complete zone, you will be able to replicate, or you will be able to get the data again available in the second scenario where you have the persistent disk available within the zone. Okay, but what if complete region itself is down? Now in that scenario you will lose everything from this data. I mean, you cannot access it, you won't be losing, I mean, that really rarely happens, but at least you won't be able to access it at that particular of time. So for that there is another way of optimization of this SSDs, where you get the regional persistent disk. So your data will be replicated at a region level. I mean, it will be the availability will be created in another region also. Okay, which helps in a durable and highly available scenario, and it's for the mission critical workloads, like okay, so are you able to read this RTO and RPO? Can you confirm?
Yes.
You can.
Okay, so okay, so this RTO and RPO, so recovery point objective and recovery time objective, these two are very important whenever you have a need for working on the backup and disaster recovery scenarios. It is a concept applicable for any sort of data related situation, either it is related to database or the block storage as well. So here what happens, you have a mission critical requirement where you cannot lose any data, any time, you cannot have any loss of the okay, two ways. So first of all, recovery point objective, so how much back you can go and retrieve the data, right? Suppose there was a failure, a zone failure or a regional failure. Now obviously it will take some time to resolve that issue, right? So how much time you can take to recover and get the data? So first is how back I can go and retrieve my data, that is for recovery of data going back to the time in the past. And the second one is the recovery time, like how soon I can recover, I mean, how sooner I'm able to get up again and then start working, right? So that is talking from the future perspective. So one is RPO is from the past side, and RTO is from the future perspective, how sooner you can get started again, right? So these are when you have a scenario where you can have it only near zero, like you cannot miss any amount of time, you cannot have any miss of any data. So in those scenarios, which is very rare, I mean, that hardly happens that you can have zero. So that's why it says that near zero, you cannot achieve zero uh, very hard, and no organization will expect that could happen. So these two concepts, please remember, these are very important from your other aspirations as well. Okay. Okay. So the use cases, if you see, in the standard scenario, you can have a Hadoop and a Kafka kind of requirement. In the balance PD, you will go for the boot disk. You want to have the web serving that you have, right? So you want to have the performance as well as the users perspective, also the cost side also, it should be better balanced. Okay. If you have a lot of performance related thing, then you can go for the I mean, from the database side, you want to persist have the persistent caching you want to scale out for the analytics work. And again, same scenario for extreme persistent disk, where you want to have the large memory for the databases. Okay. And the local SSD, as I said, this is for media rendering. I mean, you want to do the quickly analyze your data and then put it forward. So that is where you are going to go for the local SSD. Okay. Fine. So let's go back and okay. So far we covered this cloud storage and the persistent disk. Now the next one is file store. So for file store, let me just give one small update that give me a second. Yeah. So file store is nothing but you can say a large hard disk where you have the data available. Like it's a file sharing. You are aware of SharePoint, right? I mean, where you keep the data and then you exchange it with multiple people. So you can just relate it with that. So this is not much to discuss here. They are not much. I mean, the use cases are quite limited here. So I'm not going to touch base much of it. But this is a kind of a storage where you can keep all sort of data and it can be accessed by thousands and thousands of people easily for collaboration, also for other sort of work also. Okay. So not much to discuss in this particular component. Now let's move on. Okay, so let's look into the lab. So we will create a compute engine instance. I would take someone's help to share the screen and let's walk through from there. Can someone share your screen and then we will show it on your system first?
Yes, I will share.
Okay, go ahead.
You have disabled the screen sharing.
Give me a second. Can you try it now? Raju, are you sharing?
Yes, going to share.
Okay.
Google Cloud was there, no?
Okay, so
Console.
that is going to be console.cloud.
Console.cloud.
We have to do on our PCs also? Or?
Yes, go ahead. Start doing that.
Okay.
Yeah, let me pause the recording for time being.
I don't understand.
Fine, I have started it again.
Okay.
Okay. So far what we have covered, we talked about the steps or what are the configurations on the compute engine instance. Now in that we saw how to create it using the console. We created it using the command line. So Raju, can you share your screen where you run the command line way of creating the instance?
Okay, so this was the command line.
Yeah, you can just I mean increase move it up. It is already open, no? You have to scroll.
Okay.
Yeah. Yeah. Okay. Now if you can use the up arrow key, it will show what previous commands you had executed, right?
Yes.
So click on there and yeah, ls instance. One more. Yes. So
This is
this was
the
the command. This was the command that you have executed to create the compute engine instance. The command, if you try to understand or read, so it has the very first command as gcloud, like
Okay.
we saw for the Kubernetes concept. We saw Docker as one command, which is a CLI for Docker. For Kubernetes, we have kubectl. Similar to that, for GCP environment, when you're working, they have a command line SDK for gcloud. Now, after that, you are passing it on the set of things that you want to do. So the second component is here the service. What service we are going to create? That is compute. Okay, and in that compute, I'm going to create an instance of from the compute engine service. Okay, then I'm passing the instances, and then later on, what I'm actually going to do, that is creation of the instance, not updating, not patching, but I'm creating an instance, giving the name of the instance. Okay, then you have the project name. So the project name that you are using here is, you can also see highlighted with yellow color in that cell. So the project name here is stable vault, right? Stable vault 383204. And then you have the zone under which you are creating this machine, the machine type, and similar to that, the other properties of the compute engine whenever you are going to create it. Okay.
These things I have to remember, or how we can give
No,
this
you have to
solution?
understand it. You don't have to remember anything. You have to understand it, what they mean,
Okay.
how the topology is created for this, right?
Okay.
Now, so you have already created these VM instances using the command line. We have seen the steps for creation, or what all things are there when you are accessing it through the console. Okay. Can you share the screen where you have SSH into the VM? You have already opened it, right? Is it running, Raju?
Yes, it is running.
But
Not visible.
you are not sharing.
Okay. Can you share? Okay. Is it visible?
Yes, now we can see it. So this is the VM that you have run by yourself, and you can do all sort of things. You will have you can install all the components, right? So everything that you can do over here, you can actually install a web server and create a web page, and from you can access it, or host your own website, right?
Okay.
So there can be a lot many use cases, but this is how you create a VM on Google Cloud Platform. Okay. Now let's go back and delete it.
Okay.
So you can close this one.
How we can directly exit, or what?
You can directly exit. There is no harm. Yeah. Okay. You stop sharing.
Yes. Okay. Let me share again. Is it visible now?
Yes, it is visible. Now what you need to do, you can select that VM.
Okay.
Okay. Which should enable few more options. Okay. Can you go to the right hand side and you see, okay, here you can see. So you have an option for delete. You can go ahead and delete the machine. Okay.
Done.
Yeah. Now let's go back to the Terraform code that you have written. I mean, here, open the editor.
Just a second.
Down, you can see you have this open editor.
Open editor.
It is integrated with the cloud cell. Okay, so it is not a part of something else, but it is editor that is provided by cloud cell itself. Okay, you will have a provisioning of around 5 GB of space here.
Okay.
And if you are not using it like for some time, it will archive whatever data you had earlier, or sometimes it you also lose the non-persistent ones.
Okay. Is that chargeable, or what?
No, this one is not chargeable.
Okay, this is free. Okay.
So, Jitendra,
Yeah, go ahead.
Now you are recording.
Mhm.
So I want to share my screen, and then can we go quickly through this process? So I have tips.
Yes, Vishal, we can do it. Are you ready with the Terraform code?
Terraform. Okay.
Okay,
Mm,
let's continue with you. That's completely fine. Naresh, you are able to follow it so far, right?
Yes. Yeah, I'm following.
You are ready with your Terraform code also, correct?
Yes.
Okay, that's fine. So let Vishal share it, and then we'll continue with Vishal now.
yes. Thank you.
Yeah, go ahead.
Not sharing allowed.
Yeah,
Release.
he's already sharing it. Raju, can you stop sharing? Okay, that's fine. Okay, start sharing now, Vishal.
Okay.
Okay, good.
Yes.
Click on create instance. You can change or you can let it be everything as it is, or just change this one part. Okay, yeah,
Yes.
that's better. Okay, now come down. You can see equivalent code. Click on equivalent code. Okay.
What is the language for coding here?
No, it's not a kind of a language. It's just a set of command line instructions.
Okay.
Okay, it's not a language.
Okay.
Now, we have already explored it with the command line when Raju was sharing the screen. Can you click on Terraform and we'll take it forward from there?
Where is Terraform?
Just there itself, yes. Copy everything. You can copy it from down. There is a copy command,
Yeah. Okay.
right? Okay. Now click on Cloud Cell button on top of the same side, right of it. Yes.
Oh, this I have to open always in the incognito mode. Then this is not working.
Your company, it is not allowing. This is the concern.
But I am not on VPN.
Click on Terraform first. Right. Copy it.
Okay.
Okay. Now, yes. Now on the Cloud Cell, you can type edit or use this new word nano.
No. Okay.
Yeah, space vminstance.tf.
vm-engine.de.
Yeah, any name that you can use. No, it's a TF, Terraform, right? So TF. Okay, yeah, enter. Just use Control V to paste it. Yes, it is pasted. Now you have to use Control or just Control X.
Control save.
Control X. Control X.
Control X.
Yes. I don't think it is saved. Do ls. Type ls and enter.
Enter.
Yes. Okay, it is created. Okay. Click on write more and then give the name of the file. More space. No, more space.
More space.
Yeah, VM.
VM
Enter tab.
tab.
Press tab. Yes. Enter. Okay, we can see that it has created. Now you can use Control C to exit.
Control C.
Yeah. Okay. All good. Now,
Okay.
so you can see this is a Terraform code which will create a resource for me. Okay. Let's also open it with the editor to explain you what this code does and how it does. Click on Open Editor.
takes 18 seconds or more? More.
No, it may take a little extra time. 80 seconds was for creating the computing instance.
Okay.
So today again, as we are running late, we'll be completing the compute engine creation, but it's a lot of things that we have covered. So we covered the cloud storage options. We discussed about various components in the compute engine and how you can create it using the console, using the command line, and now we are exploring how to create it with the Terraform.
Okay.
Yeah. Why it's taking so much time? Can I try to refresh it or something? It should appear, the cloud shell should appear immediately. Okay. Click on editor, open editor. Okay, I'm not sure why it is taking so much time for you. So let's go back to the terminal and we will explore it from there itself. Yeah, okay. Now, again, you can use the command more and then give the name of the VM instance.
More space in
that the name? No, I don't think that you named it
VM
instance.
in short here.
The name was different. VM engine is what you have named. Yes,
Tab will not work here.
Tab will work. Tab you can try. Press tab and enter.
Yes.
Enter. Okay, and keep pressing enter button. Yeah, or maybe use the space bar. Right. Okay. Now this looks good. So can you go to the top of this output? Go a little up, and then we'll start understanding what it means. Okay. Yeah. Scroll a bit down. Okay. Now, if you see here, what all things we are having? We have a resource that we are creating, which is going to be Google Compute Instance. This is going to be a default name. The APIs are
Hello.
created by. Hello. Can you hear me?
Yes, I'm there.
Okay, fine. So what I was explaining, so this is instance that is this is the compute instance that we are going to create. The instance name is going to be instance 1. Okay. So instance 1 is a variable that we are giving. We can name it anything that we want. Okay. But Google Compute Instance is what Terraform has come up with as an API. Okay. So it will ensure that only that resource is created. Okay. And down you will see there are other variables like auto delete is true. So it will delete the data or once you exit like that. Then VM, the device name again, you have the instance 1. Okay. You have the initialize parameters. So it is going to initialize, yeah, don't scroll much. So it is going to use the image. You can see the image name that we had used. So that was Debian 11. Okay. Size of the persistent disk was 10 GB. The mode was read and write. We can perform read and write both. The IP forward that you are asking, that is false by default. If we want, we can make it true based on our requirement. Then
Okay.
you have the deletion protection, enable the display we don't want, right? Then there are some labels that we have added. Okay, so labels are VM add Terraform. That is what we are add. It is coming from the Terraform, like the automatic generation of the Terraform. They are adding some labels so that we can easily identify from where this VM was created, right? The machine type is defined. Now we have the machine type as E2 medium. Okay, and name of the instance is VM1 again. Give me another second. Can you scroll down? Can you hear me?
Yes.
Okay. So now you can see the network configuration. We have the access config, right? So here the network tier is a premium one, and access config, whenever we say, it is ensuring that we are also enabling the public IP. Okay. So we are creating a public IP. We have a subnetwork. So as you can see, the subnetwork for this project is US West 4 because we did not make any changes there. Okay. So that is what it is going to use, subnetwork as default in the region US West 4. Then you have a scheduling, so automatic restart is true. On host maintenance migrate, like if there is a maintenance scenario, you want to enable the migration of it. Okay. Then preemptible VM we are not creating, and then provisioning model is a standard model that we are provisioning. Okay, now come down. So I was talking about the service account. So this is the name of the service account, the machine ID that we it is going to create by default whenever you are going to create a VM. Okay, if you don't want any service account for running this VM or don't want anyone to access it otherwise, you can disable the service account provision. The scope of the service account is also defined here, as we have already discussed. Okay.
Yes.
Then come down, you have the shielded VM config, like that is like enable the integrity monitoring. If everything looks good or not, so it will keep on monitoring all those integrity checks. Okay. Enable the VTPM, like trusted. I'm not able to recall that complete name. Okay. So TPM module is something that will ensure that it is tamper proof. Okay. Now then come down, you are creating it in a zone which is US based 4B. Okay, and that's all. So this is how the Terraform code looks like. Now, how to create the VM using this Terraform? Let's talk about that and let's execute it. So can you click on reconnect? Okay, great. Now let's run the command Terraform in it, because Terraform is already present on the system. Let's first verify if Terraform is present or not. So type the command Terraform, Terraform. Okay, space version. Yeah, enter.
Space.
Enter.
Terraform version 1.5.4 on Linux.
So we already have the Terraform 1.5.4 installed on this machine. Okay, now let's execute your commands. So what are the commands we are going to execute? First of all, Terraform init. Terraform space init. That means initialize.
Terraform init.
Yes, that will initialize and download all the plugins on this particular VM on the cloud set. So enter. So how it is going to initialize based on what module you have in that place. Okay. I mean the code that you have in place. Now let's run Terraform plan.
Terraform
Plan.
Enter.
Yes, enter. This will check whatever, authorize it. So this will ensure whatever config file you have, as many config file you keep there. Okay, this is one file. You can have multiple files, or you can have the multiple resources in just one file that you can create over here, right? So this is displaying that what all things we are going to create. So it says that we are going to add one resource. You can see the plan. It is saying that you can see in the screen, right? The last statement that it's showing. So you are going to add just above that. I mean, where you're hovering. Yes. So you can see the plan, correct? So it is going to create 1 to add, 0 to change. So we are not making any changes to the existing resource. Okay. And 0 to destroy, nothing to delete also.
Okay.
So this is the plan that we are coming up with. Now let's deploy it. So when I want to deploy, you can see again the command. It says that it is going to, you need to type the command Terraform apply to deploy these changes. Okay, it will ask for the value. Yes is like you are accepting that you want to continue with this plan. Enter. Okay, so now it is creating your resource. The way that you had created it using the console or with the command line, same it is going to implement here also. Okay. The advantage that you are getting, it is present in the form of an infrastructure as code. So this infrastructure you can actually declare freehand and deploy it as you want. You can update it as you want, and you don't have to go with all those clicks and all. And you see the how fast it was to deploy, right?
Yeah, 18 seconds, no?
Right. So within 20 seconds is what? Okay, so it says that 22 seconds it took.
One question, Jitendra.
Yes.
Okay, so here apply complete resources. 1 equal to add, 0 equal to changed, and 0 equal to destroyed. What do you mean by that?
Yeah, as I explained just now. So 1 resource is added.
Okay.
Right.
0
was changed. So if suppose I had this infrastructure already existing. Now let's go back and then click, open the, can you click on the editor again and see if it is up? Okay, click on it.
Are disabled. Network. Click allow cookies. Allow cookies.
No, it's not allowing to cook.
Okay, not allowing. Okay.
So you have to click it somewhere on
Settings?
top. Yeah. So not here. No.
Settings, no?
No. Can you open it in a new page, new window?
This language is also German, so
Yes.
Now it has worked. Okay. Now you can click on vmengine.tf. Okay. Now let's make it can IP forward make it true.
Here, downside, down. Yes.
Make it true.
Only
Type
one.
true. Yeah,
To
true.
remove all.
That's
true.
all. Okay. And save it.
Control S will work.
Yeah. Go back to Cloud
Yes.
Shell again.
Go back to
Cloud Shell, the previous tab.
Previous tab.
with the screen.
No,
So
here
it is
in
there.
this one. In the computer engine.
Here. No, not this one.
The incognito. Yes, now it is there.
Yeah. Click on Open Terminal. Right. Okay. Now let's type the command Terraform plan again.
Terraform plan.
Enter. Now, what do you see here? The plan, what it says.
Want to change.
Yeah.
Yes.
True.
0 to
Earlier it was false, now it is true.
Sorry.
Earlier it was showing false, now it is true.
Yes. So the changes that we are doing here is again as we are dealing with one resource only at this particular time. Suppose you have thousands of resources to handle. Okay. So it will generate me a plan. Okay. So I have this existing resource. Nothing to be changed. So unchanged for so many. Okay. Then I will be adding few more resources. Okay. And there are some changes where some of the resources will be destroyed. I don't want to use this, but I'm renaming. So suppose I'm going to rename this VM instance now. So
Okay.
let's change the name of the VM instance. Go to the editor again. Okay. Now click on that VM instance device name. Yes. Change it to something like something you find VM engine or something. Yeah. My instance. Yeah. That is also fine. Save.
Control save. Control
Yes,
S.
control. Yes. Now go back and then again run the plan. You can use up arrow key that will bring the previous command. Yes. Enter. Now see what it says. So as it was able to identify the resource with the name of the resource that you have used, right? So what it will do, it will actually delete the old resource, or because with that only it was able to relate it. So it will delete that old resource and create a new resource for you. So it is destroying the previous one and now it is going to add a new one. Clear?
New name. For this new name, they totally new.
Yes.
VM. Okay.
Yes. So you have to be very careful whenever you are making the changes, and you have to be very much able to understand these scenarios well. So are we clear? Now go back and pull down this command line terminal and see the VM if it is created or not. Pull it at the center. You can see to pull it. Yeah. Okay. Go back. When on the left hand side. Yeah. Leave it. Go back.
Huh?
No problem. It will be back. Don't worry. Your instance will not go unless you have deleted it.
Yeah. I'm thinking.
or you can click on cancel also.
Yeah. Okay.
Yes. Yeah. Click on cancel.
You are in incognito mode.
No, that's fine. Again, open the Cloud Console. Type it here, console.cloud.com. Because you brought it from the the previous tab, no? I mean, it was open in a non-incognito. That's why it was going completely back. Now click on this console.cloud.google.com. It will bring it here.
Okay.
Okay. Yeah. Come down. Okay. Click on no. So go to on the left hand side. You can click on those hamburger sign, and from there you can bring the compute engine and VM instance. Yes. Go to the up VM instances.
On the top.
Yeah. Fine.
Yes.
Okay. So you can see it is created, right? And you can
Yes.
also try to log in. I mean, with the SSH.
You are saying I have to log in by.
You can you can just use this click on the SSH also. It will open SSH. Yeah, directly. There are multiple ways you can do it, but let's not explore everything now itself.
Yeah. SSH means long form?
Secure cell.
Okay.
That is a secure cell. Securely you are accessing the VM.
Authorized, no?
Yeah. So that no one else can peep into what you are doing whenever you are communicating with these machines, right?
Yes. Okay.
Yeah. So you have access to this. Now, can you check if you have a gsutil installed here? So type gsutil, gsutil. Enter. It is there. Okay, that's great. Now let's do one thing. Should we continue and complete the storage lab also if you all are fine?
Yeah, I'm fine.
Raju, how about you?
How much time it will take?
Maybe another 10-15 minutes.
That is fine. 15 minutes is fine.
Okay, that's fine. Then let's do it now. Okay, so we will be exploring how to create a bucket using console, using gsutil command, and also we will see how to create it using a Terraform code. Okay, so Vishal, can you go back to the console?
Yes.
Search for cloud storage on the left hand side.
Here?
No, on the left. Yeah, from there also you can get it. But let's go to the either way is fine.
Okay, let's do from here. So cloud storage and then buckets monitoring settings.
Yes, buckets. The buckets is the one that we want to create. Please ensure the VM that you have created, you are destroying it. So in the Terraform, if you have created, ensure that you execute one more command, which is called Terraform destroy. Let's do it now, that also before we do the cloud storage part.
I have not done, Jitendra.
Sorry?
I have not created that one, correct?
You have
Terraform?
not created. Yeah, you have
Yes.
not created.
Okay.
But if you were trying parallelly, then I'm not sure.
No, no, I'm not done.
Okay, that's fine.
Okay.
Okay, so Vishal,
Yeah.
you have to open a cloud shell to execute it. You can click on
Go
cloud shell.
back to the.
No, cloud shell is there. You can see there itself, just next to search. Yes. Yeah. Run the command terraform destroy.
Enter.
Yes. See, this is again very important step. Enter S. I mean, type S. You can and then respond. I mean, enter.
Yes.
This is again very important step, and I will give you my live example here. I went to deliver a session in Nagpur for GDG Cloud community. Okay, I gave a demo and I forgot to destroy it. After a week, after a month, I got a bill of around 7,700 something thousand. Okay, so that was like unnecessary charges because I was not using it. Okay, so that's a pain I had taken. So be careful with it.
You can see the price also. Like, where can you see the price?
We'll explain that, not now. Okay. Fine. So let's go back to the previous. Yeah, maybe you can just move it down, pull it down. Pull down this cloud cell. Yeah. Okay. Now here you can see how to create the buckets, right? So you can click on create bucket. Yes, create. Okay, give name of the bucket. Anything.
First,
Start with your name or something. No, first bucket and all that may be existing, because okay, so just remember here, as I mentioned, it is a global resource, right? It will create a unique URL for this resource, whatever bucket or the object you are going to create. So for that reason, you cannot have any common names here. So start with maybe the project name that you have. Mostly that is how we do with the test kind of scenario, like whenever we want to do a lab. So what you can do, click on my first project that you can see above the creator bucket. Top, go above. Yes, click on that. Here you can see you have a project name, so you can actually give the ID of it. ID will be unique. Yeah, take that. Okay. And then
okay.
use the ID plus you can say the bucket or something, like you can add a dash bucket.
What is saying?
You were using caps, you cannot have a capital letters. Yeah, click on continue. Now here you can see we have the multiple options. Either it is or by default it is creating in a multi-region for the duplicacy of the data in multiple regions. Okay, so that ensures highest availability. Or you can create in dual regions, so simultaneously your data will exist in another region. Okay, or you can create a regional resource which is going to be just one region. Okay, now click on, you can leave that and continue. On the right hand side also you can see the cost it is going to have.
Oh, okay.
Yeah, per month. Okay.
Yes.
Now you can see there are different classes that I was talking about: standard, nearline, and fold line, and archive.
Yes.
Right.
Yes.
Also recently they have introduced the concept of auto class just before the set default class. Yes, right. So this is for, they will try to, I mean, you are allowing it to perform the analysis, and based on that it will keep switching the classes based on the pattern, right? But the charges are going to be there for analysis purpose, right? So whatever sort of APIs calls they are going to make and keep on tracking your storage objects, so that is again going to be a little charge here. But altogether it will save a lot of data if you have a lot of data to manage, a lot of cost if you have a lot of data to manage. Okay, now continue and click on continue. Come down, you have a set of access control. Either you can make it uniform or you can fine grain it based on the objects, right? So for individual object you are going to give certain access, for other set of objects you will have separate access level. So uniform will be like all the objects within that bucket will have the same kind of permissions.
Yeah, like Google Drive items, no? You give permissions.
Yes. Yes. Actually, Google Drive is using in the backend. Google Drive is using cloud storage.
Yes. So
okay. Now click on continue.
Create.
You can click on data encryption to explore it. Again, you can see you can have the customer managed encryption key or Google provided encryption key, but by default the data will be encrypted. Right? Okay.
Yes.
Now you can click. Now you can click create. Here you can see prevent public access, enforce public access prevention on this bucket. That means it will not expose this bucket to public, and you are confirming by default. If you want to access it from public, I mean from the internet, then you can actually untick it, but that is not recommended. So you can confirm, and it will create this. Okay.
We can see a bucket.
Yeah, bucket is created. Now you have the options enabled. You can create like a, though it says that you can create a folder, upload a folder, files like, okay, but actually these are not the actual folders. The structure looks like a folder, but they are not a folder, but they are going to be individual block of block or the object, and they are having their unique URL or URI to access it. Okay, now you can click on upload files, and you can do that easily. You can take any sample file and you can upload and then remove that later. Just ensure that you delete it later on.
Like some photograph is okay, no?
Yeah, anything is fine. I mean, just take one and then you can delete it later, no? So now click on that image.
Here.
No, there you have it in the bucket. Yeah. Okay. Now what you see here, you have the type of it. So now you see immediately all the metadata. This is the metadata, right? So all the metadata about this object is uploaded. I mean created immediately. So these are actually done through the cloud functions. So it will trigger everything and it will create. And see the how fast it was able to do that. So now you got this.
One question, like yesterday we spoke about this microservices, or small application related buckets. So that is also needs to be created, or I can directly, like if I have some project in some
Okay,
software.
that is another service, artifact registry, and they are using these buckets itself, but you don't have to create it. It will take care of it.
Okay.
Okay, yeah, click on this again. You can see we have not allowed any public URL. You have the timestamp. You have the gsutil URI. Can you copy that gsutil URI?
Yes, copied.
Now you can see the versioning, retention policy, everything we have kept none. Scroll down. Okay, so encryption type Google managed. So this is how it looks. Now even you can preview your data. So click on preview. Yeah, looks good.
Yeah.
Okay, why I am showing this, let's go back. So this is one step, and the versioning is also disabled here. But if you want, click on version history. Okay, this is version 1. Now let's do one thing. Go back to this bucket.
Yeah.
Right, click on that. Now no, click on the buckets, the first node. Yes. Yeah. Now again upload another file. Yeah, it should appear. You can dismiss that. You can refresh it and then it will appear, I guess.
Refresh. Oh, here. Renew. I think I have to click this one and then it shows upload.
No. Okay, do one thing. Go to your the folder for local folder. Take that file and upload it here again. Okay, you are in the bucket itself. No, click on the bucket first. You need to go inside the bucket. Sorry, I was missing that. Okay, yeah, here you can see. Yeah, sorry, I was confusing it with the object name itself. Yeah, okay. Click on upload files.
This time let's do upload folder.
No, take the file only. I wanted to explain some concept there. Yeah, take the same file. Same file. Yes. Yeah, that only. Upload. Okay.
Already.
Enable object versioning. Okay. Apply the same. Okay, so you can, okay, so actually we have not enabled the object versioning. Otherwise, what it could have done, no, it could have uploaded it, and then you will see two versions of the same. Okay, click on overwrite object.
Continue.
Yes. Okay, this is just that we have not enabled versioning. Otherwise, it could have duplicate. Created a version. So click on object again, and if you see, it is. Yeah, click on versioning, version history. No, so we have this is your live object only. Anyway, that's fine, but that is a concept that you should be aware that how the versioning works. You have to enable the versioning so that you can keep on creating multiple versions of the same data with different timestamp, right? Okay. Now you have already copied this URI. Can you copy it again? Copy the URI again. Yes. Go to the VM instance that you are running, or you have already deleted that, right?
That we deleted that.
Okay. No problem. We can do it with the Cloud Shell as well. So open the, scroll up the Cloud Shell.
Yes.
Yeah, open that. Yeah. So from Cloud Shell, you have direct access to this bucket. Okay, the object also. So now what you can do, you can type the command gsutil. Yes. Space.
Space.
rm. space, enter that, paste the URI that you have copied. Yeah, enter. Enter.
Removing. Okay.
Yes. Now if you can go back, yeah. So this is how there are multiple other commands that you can explore, but this is how gsutil command will work like any other Linux command that we use, right? So most of it is covered there. So using gsutil command, you can create the object, you can create the bucket, you can delete, you can play around with it, all of stuff that you can do. Okay.
Yes.
So all of those things you can perform using the this command. Fine.
Util, gsutil.
gsutil, yes. GS is for Google Cloud Storage, okay, and util is like utility, right? So like that they have named it. So that's how we use it. Fine.
Okay.
Yeah. So that's all that we are going to cover for today. And let me share with you all the links for today's session.
So we have already these links in the Google Drive, right? You save in that file also, or we have to save it again?
I'm sharing it, but for your quick reference, I'm giving it here. Fine. Now, the link that I have given, even for labs also I have given you, which is going to be more useful based on like how much you want to explore it. So you can try it out for compute engine as well as for the cloud storage. Okay. So let's stop the recording now.